this particular worksheet that I pulled, it has some opposition to putting parentheses around things that are inside trig. So if I pull any others from this, technically those are supposed to have parentheses around them. Okay. It also put the equation stuff on the left, the number on the left, and the equation on the right, which it doesn't really matter, but it somehow looks a little bit backwards. So, but it doesn't matter. All right. So I'm going to show you how to do the first one. Notice we are only going from 0 to 2 pi, which means we're only looking at one revolution around the unit circle. Okay. All right. My goal is to try to solve this, and so I'm going to isolate the trig first. So what do I need to do to move this 2? Subtract it. So we're subtracting 2 from both sides. So that gives me what's 2 minus 2. So 0 equals 1/2 sine of theta. All right, what do I need to do to still isolate the trig? Okay, we're going to multiply by 2 or divide by 1/2. Either one of those would work. So I'm going to choose to multiply by 2. What's 2 times 0? 0. So 0 equals sine theta. All right. When we are solving, we are looking for the radian measure. That's why it said the 0 to 2 pi thing. Okay, so our answer should be in radians. Okay, so I have to think about where I'm going to have 0 as the sign part of the coordinate on the unit circle. Without having my unit circle in front of me, that's the new layer of fun. Okay, all right. What is sine? Is sine the x value or the y value? Y value. Good. Okay, so if I think about it, it's only going to be 0 on the quadrant angles, right? In this particular case. So I know that I'm out 1, up 0, out 0, up 1, out -1, up 0, and 0, -1. At the least, get that on there, right, when I have 0. All right, so which 2 radian measures is the y value 0? Zero. Okay, good. I like 0. So it's 0. So theta equals 0. What else does theta equal? Pi. Good. Why wouldn't I use 2 pi? There's a really subtle thing. Look at what I highlighted in purple. Is 2 pi included? Now, see how there's no equal to there? So 0 wins in this case instead of 2 pi. Okay, so that makes sense. So you always start with 0. 2 pi is technically not included in that interval. If it is included, then we would have had 3 answers. Okay, we do 0 pi, 2 pi. Okay, all right. Let's take a look at number 2 together. I tried to pull one of each type. Okay, so we have one that's a sine, one that's a tangent or cotangent, and one that's because sine and cosine are going to act the same way, tangent and cotangent are going to act the same way, and secant and cosecant are going to act the same way. So I tried to pull one of each. Okay, all right, but we'll do them together today. Have you do them on your own tomorrow. All right, I got to isolate the trig. What am I going to do first? Subtract 5. Okay, so what is 9 minus 5? 4. Good. Minus or equals -4 tangent of theta. You don't have to have the parentheses really when you just have a theta, but it's up to you. All right, I still am isolating the trig. What do I need to do? Divide by -4. So it's 4 divided by -4. -1 equals tangent of theta. Okay, now we got to start thinking about our unit circle. We know we're going to get 2 answers. Okay, there's always at least 2. Okay. All right. So, which quadrants is tangent negative in? So, which ones is it negative in? 2 and 4. So, I'm looking for something in 2 and 4. Okay. If I have to get -1 is the answer, my x value and my y value have to be the same, right? But in this case, because it's -1, same with opposite signs. All right. What x value and y value come up that are the same every time in our unit circle? Square root of 2 over 2, right? Square root of 2 over 2, square root of 2 over 2. I believe the first one's negative there. Square root of 2 over 2, square root of 2 over 2. This one's negative, right? It doesn't matter which one's negative, right? Okay, what radian measures is that happening at? Well, what's the denominator of the radian measures? 4. We're thinking radian measures, right? Not coordinates. So you're right, it is 2, but 4, you got to go back to radian measures now. We're trying to work backwards. So it's got to be 4. Okay, and then you got to count, right? 1, 2, 3 pi over 4. Yep. 4 pi, 5 pi, 6 pi, 7 pi over 4. There is a ton, not a lot of written work, but a ton of thinking in there. Okay. If you need to scribble more onto your unit circle, do it. But you see, I don't need the whole unit circle to be able to solve that. And I have to be able to try to do it without having my unit circle in front of me. Okay. That's our goal that we're going to. Okay. All right. We good with 2? All right. Let's do one more here. So now let's do one with secant. Secant, though, what's different about the inside of that trig compared to the other two? There's a 2 in there, so that one has a multiple angle in there as well. Okay, so probably when we take the quiz on Friday, there'll probably be one with a multiple angle and one without. Okay, all that it means is that there's a number in front of the angle when we talk multiple angle. Okay, starts the same way. What am I going to do first? Good, so 13 minus 5 is what? 8 equals 4 secant of 2 theta. All right, now what? Good. 8 divided by 4. 2 secant of 2 theta. Did you notice how I always wrote those separate over here? I wrote it as 2 separate thetas. This is why. Okay. So I need to know where 2 theta and 2 theta. So I need to separate it kind of like zero product property. Okay. All right. I still have to determine unit circle stuff. What? I can't read secant right off the unit circle. What can I read right off the unit circle? Cosine. So what is cosine of 2 theta supposed to be? If secant is 2 over 1, what's cosine? 1/2. Good. All right, and that's really scribbled. Okay, so let's think about it. Which quadrants is cosine or secant positive in? 1 and 4. Good. Is cosine the x value or the y value? X value. Okay, so I know that this coordinate here is 1, 0. I can probably get it based off of that one, right? So 1, 2, 3 would be up here. So that would make this one the 1. Everybody good with that? So this has to be one of my winners. What radian measure is right there? It's over 3, right? So in this case, it's going to be 1 pi over 3. So my first one's pi over 3. Okay, my little c is kind of in the way. I'm going to move it out of the way. I should have written it way further away. All right, so in this case, my y value is 1, 2, 3, and then my x value would be 1, 2, 3. I really only need this, right? There's my 1/2. That's positive for cosine. I need to know what radian measure this is. What should the denominator be? Still going to be 3, right? I just have to figure out what my numerator is. It's something over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. What are we going to get? 5. Do you see how counting those wedges is super helpful? Okay. So I taught it all. We never really brought it together in this context because I never made you do it without your unit circle, right? We ran out of time. Okay. All right. That's why we're picking it up now. All right. I'm not done yet though, because do I have theta by itself? No. So this is the last step of this one is you have to multiply or divide by 2, right? Divide by 2, remember, is the same as multiply by 1/2 on both sides. Okay. So theta equals what's pi over what? Pi over 6. And in this case, it would be 5 pi over 6. Sometimes on these ones, you get something that's on the unit circle. Sometimes you don't. Okay. Sometimes there's 4 answers instead of 2 answers. Okay. Just depends on the problem. Okay. All right, that's all we're going to do for that today. Okay, we're just practicing that 5 minutes. Okay, which is probably more than 5 minutes, but that's okay. All right. The next thing I want you to put in front of you is, I know what